Okay, welcome class. In this video, we will discuss about the interview series, Python interview series 1. And this series has around 50 questions in different 5 parts. Each part is having around 10 questions. These questions are mostly frequent asked questions in interviews. And in today, we will have an exercise from each section. We will pick 2 or 3 random problems and then we'll solve it. Remaining, I'll share with you, and you have to complete the assignment and submit to me. So in this part, we have reversed a string without using built-in function. I think you have already done it. So there are a couple of ways. One is you can use slicing technique, right? Or you can use loop with range function. So this we have already done it. I think we can take this up, check if a string is palindrome or not, right? And then there is a third problem, count vowel and consonant in a string. And then next is convert a string to title case without using title. So then we have removed all spaces from a string. This we have performed, right? So then we have count occurrence of each character in a string. You can use count function, or without that you can iterate through the loop each character and use dictionary to store it. There are a couple of ways you can solve it. Then find the first non-repeating character. Find the most frequent character in a string, right? Check if two strings are anagrams. Remove duplicate characters while preserving order. So these are the 10 questions from a string. Out of these 10, let's pick, this is the first question. Check if a string is palindrome or not, right? Yeah. So let's say we have an input string and we are taking an input from user. So there are two ways to take input. One is you can take a fixed string, like having a variable, let's say str1 equals to apple. This is one string. Okay. And this input you can use to take input from the terminal. You can take input here from the user and then use it. So let's use this because we haven't tried it. Then I'll take this input as into the string variable. And what exactly palindrome string is? So what exactly palindrome is? So any string or word uh, that reads the same backward and forward. For example, let's say we have a string madam, right? This is one word. So if I read it from this direction or if I reverse it, then it have both ways same meaning, right? So if I reverse it, then I'll get again madam, right? And for example, we have another string label. If I reverse it, then it is same, right? Label. But if I say Python, so Python is not palindrome. Why? Because if I reverse Python, it creates an O H H T Y P, right? So which is the reverse of this is not equal to this. So if you see the problem itself and the solution, it is straightforward. If the reverse of a string is equal to your input string, then it is a palindrome string. So what we can do is we can solve it in a uh, single statement. So you know very well how to do reverse. So let's say reverse string equals to input string of this, right? Input string double colon -1. So this returns you the reverse of the string, and then we are storing into rv underscore string variable, and I'll make a check if input string equal to reverse string, Then we will say it's a palindrome. Else, we'll write the else part. Else, we will print whatever string you have given as input is not palindrome. Right? Simple. So let's run it, and I'll enter I am a DM madam. Right? So if you see, madam is a palindrome. If I run it again and I say Python, then it returns Python is not a palindrome. This is the way you can create the logic. And sometime in interview they ask, do not use any built-in or any available functionality of Python. Then how you will do it? So we have my looping concept. So what I suggest here is use two pointer technique. For example, let's say you have this string am a d a am, right? First pointer you can keep here. This is your left, right? And this will be right. The right, and then we can compare both. So let's say if we say left equal to right, and then if yes, right, go to next element and it will come back. So in same loop, we will be iterating from left and from right, correct? And then we'll compare each item, and we have to stop when left become right, right, or greater than right. So means if I say I want my loop until my left is lesser than right, correct? So in this case, I will be iterating the half of the string, and I am able to compare it also. And this is where my time complexity also lesser. So let's solve this way. I'll use a while loop instead of for, which is easier comparatively to use in this case. Anyway, the while loop also will cover in looping section in detail, but I'll explain here. So let's say my left is 0th index and right will become the length of input string minus 1. So if you see, the length of the input string is 5, right? And if I do the indexing of this 0, 1, 2, 3, 4, so my right become 4. So 5 minus 1, 4 in this case, right? So that is why I taken right as length of input string minus 1. Then there is another loop in Python, while loop. So instead of for, you can use while, and this is a keyword, and then condition. So if you see, my condition says left is lesser than right. Until that, you continue your loop, right? And this is something we can see here. Input string of left, if input string of left means index is not equal to input string of right. So whenever I get this condition, I'll say this is not palindrome, right? Because whenever I get this condition, then it fails. And anyway, I'm iterating until mid minus 1, right? I'm not going for D, where left and right becomes equal, right? I'm not iterating to this condition. My condition is always till my left is lesser than right. Then we are increasing left, right? Incrementing to 1, and right I'm decrementing from 1. So if I do not find any case where this condition is satisfied, then anyway the input stream will become palindrome, right? So now if I run it and say I'll enter a string label, so if you see, with both solution, this is one solution, right? So I'll say solution 1, and this is solution 2. So whatever problems you solve, try to solve in with solution or 3 solutions for more practice. Right? So now if I say, let's say Delhi, so Delhi is not calendar, right? So next problem is, let's say, count vowels and consonants in a string. So what we need to do here is, let's suppose we have a string, and within that string we need to count how many vowels are there, how many consonants are there. For example, we have Python is great, right? Let's say this is a sentence we have. Now what we need to do is we need to start from starting of string, right? Iterate each element one by one and then check whether these elements or the characters are belongs to vowel, right? If it doesn't belong to vowel, for example, vowels are A, E, I, O, U. I'll keep this for verification. I'll start a loop on it, right? And then loop the iterator, for example, for I in str1. So I'll start iterating on str1 or input. So I will become P and I'll have a condition saying that if my I belongs to this group, then I will increase the counter of vowel. If this doesn't belong to this group and it is alphanumeric, then I will increase the counter of consonant. Okay. So this can be the one way to solve it. So let's take an input string, right? And then there are two ways. One is either I will keep my vowels a small letter and caps letter both, or I can convert my input string into lowercase. Right? So the better or professional way in programming is you convert your entire string into lowercase first. So let's say my now the input string is L underscore string equal to input string but lower. So I have converted the entire string into lowercase and then I'll keep my reference vowels as A, E, I, O, U. Now I'll start two counters. One counter is let's say vowel count, right? Vowel count. I'll start from 0. Same for consonant also. There will be two counters and I will start my loop. So the loop will be loop character in lower string, which is the converted here, right? If character in vowels, then vowel count will be +1. So means we are checking here the character of string belongs to vowel. Then we are increasing the counter of vowel. Else if this is our next condition, else if character dot is alpha. So as I said, we are checking it if it is a alphanumeric or not. So there is a possibility when I will have space or maybe numbers or special characters. So that is why this is the condition which we are checking it. So if character doesn't belong to vowel and it is alphanumeric, then we are incrementing the consonant count. Right? So if now run it, so let's say Python is great, full stop. So the number of vowels are 4, consonants are 9. So if you count here, so we have vowels O, I, E, A, correct? And consonant P, Y, T, H, N, S, G, R, T. If I do not use this condition, then there is a problem. So let's suppose if I do not consider it. I'll just directly go to else condition and increase the consonant count. Right. So what will happen in this case? See here, um, Python is great. Full stop. See, the vowels are 4 means this condition is okay. But when it comes to else part, it is calculating your space and full stop as well. That is why it becomes 12. Right. So we should take care of this condition. That is why we are writing elif. Yeah. So let's take the next problem from part 2. Maybe we can pick any one of them. Let's say reverse the words in a string. This we can take. So what we need to do here is, let's say you have a sentence. Let's understand the problem first. So the sentence is Python is great, and this is a sentence. Now I want to reverse each word in its place. For example, Python will be reversed and O H P Y P S I T A E R G, something like that. So we are reversing the word in same position. We are not changing the position. So let's say we'll take a user input. Instead of a string, I'll say input sentence. Maybe just a variable name. Okay. Input sentence. We'll take a sentence from user, and then will what we can do is, there are multiple ways, but one of the way is I can split it. Right. There is one predefined function available. You can split it by space. So if I split this entire sentence, then it will be splitted into a list, right? List of words. Python, one word is like this. So like this, you can do that first, right? And then you can do the reverse at its position, right? Doing the reverse. And then you can apply logic for join. You can join it again. Once there is a predefined function available for a string. So you can join it uh, with the space again, because you have split it by space. You can join it again with the space. That is the way we can do it. So let's say here I say words, right? Words equals to input sentence dot split. What it will do, it will create a list of splitted words, right? And then I'll have a reverse. So this is one function already available. This function you can use for reversing. If you see here, return a reverse iterator over the value of given sequence. So you can do like in other way as well, like creating a reverse of each word, then join it, right, in the list, or you can use reversed for complete list itself. Okay, and if I print it, see the output. Let's say Python is great. So the reverse is great is Python. Okay, so it created the reverse of the words, but word wise. Okay, this is one like other problem, but we can do this also. So reversing each word at its own location. Okay, let's try to achieve that. Now this is one problem you can solve in this way. So what I did is I split it the words. So words is a list of all the words, like Python is and great. and then I'm iterating each word, then appending to reverse word list, which is my blank list initially. And what I'm appending to it, the reverse of the word, right? So I'm reversing each word at its own place, and then I'm joining it. Okay, Python is good, right? Something like that. The previous solution was, so that can be another like follow-up question from the interviewer. They can say, okay, you need to reverse the words at its own position, but in a sentence form like this. Python is great, great is Python, something like that, right? So if I use this one, this solution, this is one another problem. I'll take input again. I'll say Ram goes to market. So if you see here, what it does is it reverses the same position, and if same sentence I feed to another logic, then what is happening? Market to goes Ram. So it creates the reverse of the string, but the values within that word is same. Like we are not reversing the word, we are reversing the sentence. That is the difference. Okay. So this is a solution for our problem. This is another problem which you can solve in this way. Now, these are couple of questions which you can try out. And let's suppose 19th one, we can try out this one. Compress a string using a run length encoding. For example, A, right? So encoding says if I have 3A's, it will become A3, and I have 2B, then it become B2, right? And so on. So now let's understand this. We are compressing a string using run length encoding. And how exactly it works? Um, to create like this. So let's suppose you have any string B, 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 C, C, D, 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 like this. Right. Now, run length encoding says if you have three, like the number of phase frequencies, so let's say one. It's like immediate, right? A, how many times? One, two, three, four. It will become A4, then B3, then C2, and D3. So this should be the output. This is the expected output, right? This question also asked in interview, a lot of interviews. So let's understand it, how we can do it, right? So the algorithm is, let's say you start from first character. You have this character, right? You can access that, then count how many times it repeats. Okay, let's say these are the 4 times it repeats. And when character changes, then when you have a character change, means you are getting a B, then append character plus count. Okay, and then continue till the end. So let me solve it first, then I'll explain it again. We'll have iteration. So let me go here. My input is, let's say, input a string. Then I will store a result here. Let's say result equals to this. Right? In this string, I'll store result. Then I'll start my count from 1. Why I'm starting my count from 1? Because at least one element will be available for the particular type. Let's say A, at least one count is there, right? If I'm getting another character B or C or D, at least we have one into it, right? Then let's apply a loop on it. For I in range, I'll start from 1. Why I'm starting from 1? Because I'll start from this second instead of from this, because this is already there, right? At least this will be there. So I'm starting from this. Okay. Then it will go till the length of input string. So whatever input is there, it will go till the end. Now let's apply the logic. If input string of I is equal to I minus 1, then we are incrementing count. So what exactly we are doing here is, see here, we have a indexing A, B, B, B. So 0, 1, 2, 3, 4, 5, 6. I'm starting from here and comparing from my previous character. And if both are same, then I'm incrementing the count. Then counter will become 2. Right. Then again I will go to the next element. I'll compare it again with my previous. If both are same, then my counter will become 3. Same for this also, counter become 4. When I'm incrementing towards this, and now the condition is not satisfying. B is not equal to A here. Right? This condition is false. Then we are having another counter. Okay, where we will have like this. So we'll update two things. One is result. Result will store A and 4 like count value, and then our count will become 1 again. We are resetting it because it's a new character for us, right? So same thing is happening here also. Here, hmm, mm, uh, here we are checking the same logic. If your previous and current character is equal, then we are incrementing the count. If we are getting not equal, then we are appending to a like result input string. This is your string, the character, and the count. And then we are making a count 1 again, resetting the count. Right. Then when it is done, and if I say, let's say print result, see the output. This is not the final solution. There is a one logic also required to implement. So let's say my string is A, B, B, C, 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 D, D, E, A. Right. And if I enter this, see here what it says. 3 times A3, 2 times B, B2, 3 times C, 2 times D, then E is 2 times. The leftover part is not covered. It should be A2 also, right? Because this is the leftover. That is the one missing point here. So we are not covering this statement again when this condition is true. We are not appending to it, right? So we need another append onto string. We need to concatenate it again. The final results, right? Like this. Same. This statement I have written here also because I am not covering the last part. To cover the last part, we need this. again. Okay, now if you see, I'll say A, B, B, D, D, F, A, C, C, like this. Um, C2, white is, one second, one second. Okay, I have put it into loop. That is why, my bad. Okay, so now A, B, B, C, C, F, F, E, E, B, B, D, D. Yes. A3, B3, C2, F2, E2, B2, D2, like that. Okay, now we have next question is check if two string different by exactly one character. You try this problem. This is an no, very good problem. Now I'll move to part 3. We'll pick around two problems from part 3 and then part 4. We'll see. So reverse a list. We know very well how to do that. Find the largest element in list you have met and then find the second largest element in list. You try this. This is also very easy problem. You pick the largest and there are multiple solutions to it, but you can try in that way. Find the largest, remove it, and then get the largest again. That is the easiest way to do that. Remove duplicate from a list, right? So you can check. The easiest way is you are now iterating through the list and picking each element one by one and checking whether this element is available in the list. You remove it, pop it. That is one way. Other way is you can use SAT. I will be covering SAT in coming lectures. Find common element between two lists. So again, you can either iterate through the list and get the common elements, checking in both the places. Right? That is one solution. Other solution is you can create a set and then find out the intersection of both sides. You can convert the list into set. Okay. This is also easy problem. You will be able to solve it easily. Count frequency of elements in a list. So you have count predefined function, but we will not use predefined function here. You can use dictionary. That is one way to solve this. I'll be teaching dictionary in coming lectures. So after that, we'll solve this problem. Now, this is a good problem. Check if a list is sorted, right? So this is something now we can try out. Uh, so what is the meaning of list is sorted? Let's say element from the previous pointer. We can have two pointers again here. One pointer starting from index 1 and one pointer starting from index 0. And then you are matching or you are checking if your uh, right is greater than left, uh, then it is sorted. Else condition will fall. Right, it is not sorted. So maybe let's give a try this. We'll have input list 1, 2, 3, 4, 5. Right, this is one, and another input I'll take unsorted. Let's say input list 2. I'll name it as input list 1, input list 1, and input list 2. So there are two inputs, and we need to verify which list is having sorted elements. Let's suppose you have 1, 2, 3, 4, 5, and another list is 3, 2, 1, 5, 6. Right? This is another list. List 1, list 2. Now let's say index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Right. I'll pick each element one by one and I'll start the loop here. Right. This can be one pointer for me. Okay. And this can be another pointer. So if I consider this is if let's say this is I for me, then this will become I plus 1 in case of loop, right? If I apply loop like this for I in range, and my range will be length of L1 minus 1, correct? Because I want I plus 1. Okay. So condition will be like this. If L1, L1 of I, so I is 1, right? Sorry, 0. The value of index 0 is 1. If it is greater than L1 of I plus 1, if I get this condition anywhere, like when I'm iterating the list, then okay, I'll print like this. Okay, this is not sorted, right? Not sorted, and I'll break my loop here itself. So anywhere, if I found this condition entire list, then I'll say this is not sorted. If I do not find any condition there, then at the end I'll say this is sorted. Right? Simple. So what will happen is at each time I am comparing the elements. I'm comparing 2 to 1, then again 3 to 2, then 4 to 3, then 5 to 4 in pair. Right? Similarly, if I go here, if I say my L2 of I, which is 0 for first iteration, is greater than L2 of I plus 1, means index 1. If you see, this condition is true, right? If this condition is true, means I'm breaking the loop here itself and saying this is not a sorted list, correct? This is the logic. So let's implement it. Okay. So for I in range input list, I am matching it. Whenever I found this condition true, I say it is not sorted, right? And then I printing list is sorted. Now, if I run this, the output is list one is sorted, but the handling of this is not right because let's say if I pass here 2 input list 2, then it prints list 1 is not sorted. I'll just, let's say if I'm passing this list 1, list 2, and list 2. Right. If I'm passing list 2, in this case, if I run it again, see the problem is list 1 is not sorted. This will be executing. And anyway, this statement is always executing. That's the problem here. Okay. So how we can overcome of this problem? Uh, there are like multiple ways. I will say the easiest one. You can say a flag, right? Flag is true. So before the breaking, what I can say is I'll say like this. I'll mark my flag false. Correct. And instead of printing it here, I'll take my final decision here. I'll make another no statement. Flag, if flag is true, then we will print L1 is sorted, right? Else we will print not sorted. This is how you can handle it. And I'll remove it. So in this way, you can introduce a flag, and based on the flag's value, you can decide whether it is sorted or not sorted. So now let's pick the next problem. Okay, so we have rotate a list by key position, find the missing number of sequence in list, merge two sorted list. You try these problems. Then I'll pick something from part 4. Flatten a nested list. It's very easy. You go through the depth let's say if you have 2D or 3D, you need to go to the that left that depth of the list. Let's say 2D. Then you have a one loop, then again one loop, get the exact element, and then add into a the final list. Maybe we can take this also. This is very common problem. Okay, so the problem here is we haven't read about the recursion. Recursion is the best practice for that. Um, you, let's keep this problem. I'll solve it after the recursion when we will read about the functions and recursion topic. Because directly we cannot solve. The depth can be any depth, right? 3D, 4D, 5D. It can have nest mixed also. So recursion is best practice for that. We'll pick another problem. Um, let's say, yeah, find pairs in list given some. I think, let me check. I think we can take this up. Find pairs in a list. This was the question asked in many of my interviews. So let's understand the problem first. Okay. And then we'll understand. So what the problem says here, let's say you have a list. Let's say we have a list. List looks like this: 100, 200, 300, 400, and then maybe 250 something. And my target is, let's say, 300. For example, my target is 300. I want to get the pairs whose sum is 300. Okay. I'll extend this first. One second. I'll extend more. So 150, comma 150, right? 120, comma 120, 180, like that something. So now let's say my target is 300. Now I need to identify the pair uh, whose sum of two pairs is 300. So if you see here, the sum of 100 and 200 is 300. Sum of these two pairs, right? 300. Sum of these two pairs are 300, right? Like that. So we need to identify the pairs, okay? And it's not mandatory that they will be a subsequent. It can be anywhere, right? But it should be the pair. We cannot consider this, or this. So let's solve this problem. We will use brute force technique to understand in depth and easy to solve. But the time complexity of this way will be higher. Um, let's solve it with brute force first. Brute force is very simple. We will iterate each element one by one, and then we will understand. So let's say you have L1, 1, comma 2, comma 3, comma 4, 5, right? And then my target is 5. Right. In this case, there are two pairs. One is, uh, yeah. So let's now try to solve it. Using brute force technique, what I'm going to do is, I have taken examples separately here, 1, 2, 3, 4, 5. Let's take the same example here also. Otherwise, it will be confusing for you. So 1, 2, 3, 4, 5. My target is 5. Right. So now what I will do, I'll have a loop. I'll start from each letter, and I will apply another loop, a nested loop, which will iterate for all the elements. For example, let's say I start from this 1. For 1, I will start the remaining elements and will check. So let's say 1 plus 2, which is 3, which is not equal to target. So this is not the eligible candidate for me. Now I'll move to 3. So 1 plus 3 becomes 4. This is also not eligible candidate, right? Or the pair. Then I will move my the nested loop to next element 4. If I say 1 plus 4, that will become 5. Means this is my eligible candidate. So one pair I identify is 1 and 4. Then 5. 1 plus 5 equal to 6. This is also not eligible. Then I will move my outer loop to the next element. Now next element I will become this, right? And j will start from next. So I'm not starting from this because we have already compared it, right, with 1. Then 2 plus 3. 2 plus 3 become 5, which is your equal to target, means yes. So now this is next pair, right? Then j will move to the next, this one. So 2 plus 4 equal to 6, which is not eligible because it's not equal to a target, right? Then 2 plus 5 will become 7. This is also not the target. Similarly, it will go for I will again increment and it will go for 3. For 3, it will compare these two. So 3 plus 4, 7. 3 plus 5 is 8, not eligible. Then again I will move to 4, j will move to 5. 4 plus 5 is 9, which is not eligible. So if you see in across this exercise, we have output 2, 1 and 4, 2 and 3. Right? These are the two pairs which the sum of elements are equal to 8. Like we have discussed, this will be the algorithm. Pick the first element, compare with all the remaining. Then you have to do check the sum of the equal targets and loop it again, like go for the next element. So now let's say for I in range, my loop will go until the length of L1, right? So from 0th to the end index of the L1. In this case, the indexing is 0, 1, 2, 3, 4. Now I'll apply another loop which will start from I plus 1, which I have discussed here, right? We are starting from the next element. So I plus 1, and it will also go till the end of the list. And this is the condition. I L1 of I plus L1 of j is equal to target. If we meet any such condition, then this will be the pair for us. Right? Easy. So let me just run it. See, 1, 4, 3, 2, 3. If we change our input values, this can be maybe you can change also. Let's say 5, 6, 7, 3, 4, like something like this. My target is, let's say, 10. Right. If I run this again, see the output. These are the pairs. Right. So this is called brute force technique. But the problem in brute force technique is the time complexity will become n square. So how we calculate the time complexity based on the number of iterations we are doing over loop. I'll take a separate session, maybe next discussion or next call. We will have detailed discussion on time complexity and then we'll understand how we calculate it. I will attach the solution of each problem, like 50 problems, with my YouTube video also. Um, you can download it from there. Um, Now let's see the other part. In tuple, we don't have much to discuss because we have limited scope. Here, unpacking, packing, we have already discussed. Right, swapping two variables. This is very easy. You try out. Convert a list into tuple and converting a tuple into list. Just you need to use class. Right. This is also very easy type conversion. So let's say you have a list L1, 1, 2, 3, 4, and I want to convert into tuple, I can say tuple of L1. Then see here, you can convert it. And you can do for tuple as well. T1 equals 3, 4, 5, something like this. And I want to convert this into list. So you can use list class, list, and put tuple here. Then it will convert into list. So it's very easier to do the type conversion here. And let's move to the next. Index, find the index of an element. You know very well we have index function. Loop through the tuple. We have already done it. And enumerate you can use for identifying the index and value together. This I will cover in dictionary. We have nested tuple iteration. You can apply to for loops. In coming class, we will have more discussion on dictionary and SAT. After that, we will discuss the time complexity so that we will have more scope. Thank you.